Polymorphism is where you have one entity, which is a plus symbol, but it works in two different ways. That's it. So you have one single entity that works in multiple ways. This is what we call as polymorphism. Now, let's take a look at it, and let's take a look at how exactly it works and how exactly this operation is performed. Now, let's start with this. If you have your own class where you want to perform plus, for example, or you want to perform some minus or multiplication or division, you want to perform some overloading of an operator like this within your own class, you can do that as well. So I'm just going to take that example, and I'm going to take that example in very short to begin with, so that we can just observe this and move ahead of this. I'm just going to take a very small example. I'm going to create a class called graph points. And as we know, graph points are where we will have 2 points in a graph or in a two-dimensional space, x1 and y1. Let's say at one point, x2 and y2 at another point. All we want to do here is find out what is the difference or distance between them. To find out distance between them, I just need to perform this particular point P2 minus this particular point P1, or just something like this. That's what I want to do. I just want to calculate the distance in this order. To do that, we know the formula for distance is going to be something like x2 minus x1 whole square plus y2 minus y1 whole square. Sorry to bring up arithmetic and stuff all the way back from high school back over here. But this is one of the simplest examples we always take because we can do this code in like 5 lines maximum, right? So when we perform P2 minus P1, remember P2 is an object of graph point, P1 is an object of graph point. We don't have subtraction function for two objects by default. We just don't have it. We need to create it by ourselves. And that's exactly what we're going to do. We're going to create it by ourselves over here. Let's do that. First, let's create a simple constructor. For a constructor, you need to have x and y, 2 points. And I'll just write self.x equals x and self.y equals y. That's all we need to know here. Now, moving ahead from this, once we go ahead to double underscore init double underscore, we have created our what we call as constructor. We can then go ahead and just start with creating a couple of points. Let's create the first point, p1 equals graph points of, let's say, x comma y, and let's say p2 equals graph points of, again, x comma y, something like this. And all I need to do is create a new object p3, which would be p2 minus p1, the distance between p2 and p1. Now, if I run this, or sorry, let's take this new file, Python 04. If I run this, it says unspecified operand tag. We don't have minus at all within this. That is what it's pointing out. It says we don't have minus at all here, which is what we need to create and so on. So the way to do that, the way for us to do that here is we create a separate function, and these functions are having inbuilt name. Again, please remember what we've learned. All functions with inbuilt names begin with double underscore and end with double underscore. This is what happens. I'm just going to create double underscore sub double underscore. This is for subtraction. Similarly, you can create double underscore, add double underscore mul double underscore. So there are various functions that are available with which start with double underscore and end with double underscore that can help create these basic functions. And we're going to use that here in our case to perform some operation. So let's do that. Let's do that without any delay. Right. So whenever a subtraction is performed, here's how it works. When you perform p2 minus p1, and you have this function double underscore sub double underscore of self, here's how it works. The first object before subtraction, this is always received as self. Please remember, the first object prior to this subtraction symbol is always received as self. And the second object that we have will always be received as another object. So I need to pass another object. Let's pass it as object, for example. So P1 will be received here as self, P2 will be received here as object. That's it. So let's perform that self, comma, object. And let's remember what we need to do. We need to calculate the following. Square root of x2 minus x1 whole square plus y2 minus y1 whole square. This gives us the distance. Now, to do that, first there's a square root. Since there's a square root, we can say it is power of something with 0.5. So anything to the power of 0.5 is square root. So we have understood square root functionality. Done. Now the next part. Within this, we have this separately and this separately. So I need to do two separate power operation. This is power of x2 minus x1 comma 2. So it becomes square. And this is power of y2 minus y1 comma 2. This will become y2 minus y1 square. And both of these need to be added. That's all. Now x2 will be of self. X1 will be of object. Because first variable we receive is always self. Second variable we receive is always object. So here P2 will be received as self. P1 will be received as object. That's exactly how it works. Let's do that. We're going to return power of something with 0.5. And that something will have power of something plus power of something else. So the first one is self dot x2 plus object. Oh, I'm so sorry, not x2, self dot x plus object dot x to the power of 2. That is x1 plus x2, however you want to call it, plus power of self dot y plus object dot y comma 2. So in short, it is power of this whole thing to 0.5. And if we do that, we should get our own value. Oh, I'm so sorry. It should not be P3 because the distance is always a scalar distance, right? It's a single value. So I'll just call it as distance. And you can just print distance, for example. This is going to be the distance. So this is some way where you can, let's say, walk through this and perform simple operations like this. I hope this makes sense. I'm only taking a simple example, but you can utilize this to um, subtract any two complex objects that you have for any purpose that you might require. Subtract, multiply, add, whatever it is that you might require over time. Right. So with this, let's now move ahead to the next part. Now, moving ahead, I'm gonna create a new directory. Let's call this as date time. This is one package we haven't learned yet. So just for us to remember, there are a few packages we haven't learned yet. Date time, relative delta, and regular expressions. Common packages that we use on an everyday life. a lot, and we should know this. We should really know this, especially for someone who might use databases a lot. Date time is quite important, and so is regular expressions. So this are the couple of modules or packages particularly that we need to know initially, and both of them are inbuilt packages that are available within Python that help us perform a lot of stuff, that help us perform a lot of operations. So yeah, let's go ahead and let's get started with these modules first. Right. Now, when we talk about date time, this particular package can just be imported as date time. Now, here's the catch. Here's the thing that you need to know. Date time, which is a package that is available, is like this. Date time package has three classes within it. We have one class called date time, another class called date, another class called time. There are other classes as well, which I'm not going to be um, walking through, which I'm not going to be looking through in detail. However, here's what we're going to do in short. Date time has a class called datetime. So whenever you see me importing just datetime, that means I'm importing this module. After importing this module, I have to then import this class separately. So if I import datetime, I will use datetime dot datetime because I need to access this class within this package. We can do this, or another way we can do this, just use from datetime. We'll just import datetime. That's pretty much it. This is another way we can do. This is another way we can work around this application to begin with. And that's exactly what we're going to do. Let's take a look at it and let's see how this works to begin with. You can either import datetime package, or you can go from datetime package. You can import datetime class particularly, separately date class, separately time class. You can do something like this. If you do this, whenever you want to access datetime class, you can just use datetime dot any function, dot now, or whatever function it is you can use. However, I'm going to start with import datetime. This means I'm importing only the package. So if I want to access datetime class, I need to use datetime dot datetime, and then I need to use a function called now, for example. So these are basic date time and date functions to get current date time and date. So we're going to get the current date time and current date using this. To get current date time, we'll use datetime package, within which we'll have datetime class, within which we'll have a function called now. Now, just one thing for us to remember before we go ahead. Datetime dot now will give us an object of datetime class. This object of datetime class has access to all the functions and variables of datetime. Variables will include what is the current hour, what is the current day, what is the current month, what is the current year, what is the current second, All of these are individual variables. These variables we can access separately, just so that we know. So if you want to get to know this is how it works. Let's start with this. I'm just going to print current date time, or let's import ice cream as well to make this better. I'm just going to print current date time. Then I'm going to print, again, sorry, not print. I wanted to use IC, right? Then I'm going to use IC for current date time dot only the date. Perfect. Right. So once we execute it, you can take a look at this. We have current datetime printed, which will give us an object of datetime.datetime. As I said, datetime is a package within which we will have an object called datetime. That particular object has all of these values: year, month, day, hour, minute, second, and these 6 digits are microseconds. If you want to go in a detailed level and identify further, they help you identify it as microseconds particularly. So that's something that is available just so that we know. Anyway, let's move ahead from that over to the next part of this. Now, this is how we can get to know current date time. Similarly, we have current date. The only difference between date time and date is date time has time as well, which is hours, minutes, seconds, and microseconds, whereas date does not have it. Date only has year, month, date. That's the only difference. If I go for date time dot date dot today, time will be now, date will be today. These are the different functions we have. In this case, I'll use the same thing. Instead of current date time, let's just make it current date. Now you can see here, hour and second don't exist because date only has year, month, and day. It does not have hour, second, or so on. So just remember, date time has up to microsecond, whereas date only has this. So the variables you need to know is year, month, day. Again, I'll specify why these are important, why we work around these a lot. I'll give you real case scenarios and we'll work around it because this is quite important. So year, month, day, hour, minute, second, microsecond. Now, let's run this. So in current date, you get only 3 parameters: year, month, and day, but date time, you get the whole thing. So this is the difference that you need to know within date time and date. Now, here's the next thing that you need to know. Many of real world examples, many of real world applications do not write date in a format. Think about it. I might use this particular format. You might use this particular format. Somebody else might use, instead of month as they can have abbreviation like OCT and then use this format. Or instead of hyphen, someone might use slash. There are a lot of different formats that might exist. And this becomes difficult to understand, right? This becomes really difficult for anybody to combine them. Think about it. Let's say we have a worldwide application that's available, and you have to get sales data from Houston, which uses its Texas, which uses its own format, and let's say another from Ontario, Canada, which uses its own format, and one more, let's say from Berlin, Germany, or Malmo, Sweden, which uses its own format, and it becomes quite complicated to work around all of these. So the best way we can play around it, the best way we can make sure that no matter what I do, no matter where I access, I get the same format of date is to create a different date format. And that different date format is called epoch timestamp. There's this running joke that the computer world began on January 1st, 1970. And I'll explain why that running joke happens. This is the start of epoch timestamp. Now, what is epoch timestamp? Epoch timestamp is number of seconds that has passed till now since January 1, 1970. This is what epoch timestamp means. Number of seconds that has passed till now uh, since January 1st, 1970. So there's this particular website called epochconverter.com. I'm just going to share this across. It's a very useful website when you want to learn it. So I'll just give you a simple scenario. I'll take 0. And you can see here, this is the current timestamp in epoch. The current timestamp is this. You can see each second it keeps increasing. That's because this is number of seconds that have passed since January 1st, 1970. So let's start with this. Let's take 0. Let's convert it. You can see 0 is January 1st, 1970. 1 will be again January 1st, 1970, 1 seconds. Then 2 is 1st, 1970, 2 seconds, and so on. This is by default Greenwich Meridian time zone, but in your time zone, this might be slightly different, given the time zone as well. But this is basically how it works. This is the idea. We can use this timestamp either in seconds, milliseconds, microseconds, and nanoseconds. But for most of our general everyday life, seconds is enough. Seconds is absolutely enough to begin with. So yeah, how do I get epoch timestamp then? If everywhere it is supported, if this is the standard timestamp that is used, I should be able to find it everywhere. I should be able to access it or use it everywhere. So to give you an example of this, take a look at, I'll give you a couple of databases that use this. Epoch timestamp, as we know, it's commonly used in everything. So the idea is in SQL, you can basically take an epoch timestamp and store it as well. So I'm not sure if it purely depends what you might be storing it in your own application or in your own usage of application, but you can take this, for instance. Another thing is there's a particular NoSQL database called MongoDB, which by default uses epoch, and you have some functions that convert these as well. So as it says MongoDB, the date objects by default, any date you store, it is stored as a 64-bit integer representing number of milliseconds since Unix epoch. So its default is to store milliseconds, but you can store just seconds or up to you, because milliseconds, think about this, milliseconds adds 3 extra digits per timestamp that you store. If you store 1,000 timestamps, that means 3,000 extra digits. These 3,000 extra digits will not just take up extra time when you access all this data, it'll also take up space. So these are some ways you look at these, you work around these that we just need to know, understand, and observe. That's the whole idea. Now, let's move on to the next part of this. Let's move on to the next case scenario. Now, with this understood, let's go on further and see how much is it used, where it is used, how it is used, and everything. Right, so we have a clear idea about this. So let's go ahead and work around it now. First thing, how do I get epoch timestamp? To get an epoch timestamp, you need to use, or let's say to convert from an epoch timestamp or something like that, or to convert to an epoch timestamp. Let's see how we can work around it. Whenever you use current date time dot, you can see a lot of functions that will be available. You have functions like from timestamp to begin with. Where did it go? Yeah, here it is. So from timestamp will convert a date time, sorry, a timestamp to date time. That is the first thing. So let's take the current timestamp and convert it to date time. So the current timestamp we will use here in epoch converter. Let's take this, let's paste it here, and we'll print current date time. Now, one minor thing here. I'm so sorry. One minor thing here. Let's make one minor change. Not current date time. We'll just take it as date time. Dot date time from timestamp. We're gonna create it and we're gonna store it as from epoch. And I'm just gonna print that. Let's see what happens. You can see this is the particular current time. So it says this is the year, this is the month, this is the date, hour, minute, and second. Now this is still second level, but you can have till millisecond, microsecond, and nanosecond level as well if you really want to. That's another thing. Now, what if I have a current date time object and let's say I want to convert this date time object over to timestamp? There are ways to do that as well within Python. So here's how you basically work around it. Once you have a date time, let's say from epoch, you just use dot timestamp. That's it. This will convert it to timestamp. So we can print the timestamp of this, which should be exactly same as what we typed. If you run this, this is what you get. But remember, it is having 0.0 because it is trying to look at milliseconds. There are no milliseconds available in our example. Our milliseconds are zero essentially. There are no milliseconds, which is why you get dot zero. So if you don't want any of this decimal point of milliseconds, microseconds, you can skip it. This is basically how it works. So this is the default format of date time we use. And we might need to perform a lot of operations on it, a lot of basic tasks on it. What do we do? How do we do that? How do we store this in database? What do we do with all of these? We're going to see these up next, possibly after our break. So yeah, let's take a break right now and yeah, let's go ahead for our lunch break and let's join back. So I think we can do that. Right. So once this is done, once we have learned date time and regular expressions, we'll go forward to database connectivity and so on right after that. Right. So yeah, let's join back by 1 p.m. Eastern time. Let's continue ahead from there. Right. Thank you guys. We'll join ahead.